So taking a look at the installation of the APIC. Again, it is a C220 server, so we do have our console port for RS-232 serial. We do have a SIMC dedicated port. We have two MLOM 1 gig out-of-band management ports. And of course, we can, and highly recommended, from your initial, when you first boot it up, before you even go through the wizard we'll talk about, we highly recommend that you go ahead and go into the BIOS, change the BIOS password, and configure SIMC to be extended MLOM so that it's shared across all 3 ports. And then, of course, we have our Cisco VIC card with 2 10 gig Ethernet interfaces, and these are our in-band ports to leafs. By the way, you cannot just use any C220 server. So there is a special TPM. There is a special way to encode that TPM or to allow the software to install. So you can't just take the ISO, download it from Cisco, and install it on any C220. It does have to be a C220 that you purchased as an APIC. And also, there is a very specific, or are very specific firmware versions that you are allowed to install on the C220 based on the Cisco ACI APIC. So pretty much what it comes with should support what you need. If there's a problem, for instance, maybe you can't get KVM to come up properly, the JNLP Java Web Start file downloads as an empty file, something seemingly trivial like that, but important to be able to manage your KVM or serial over LAN or something like that. Then you can go talk to Cisco, you can go look up in the documentation and the software downloads, but there are specific firmware versions for the server, for the BIOS, even for the VIC card that have LLDP capture, or really LLDP capture disabled, that would normally be used on a VIC card for instance, Fiber Channel over Ethernet FIP. Okay, so that's disabled so that it doesn't really capture and usurp that LLDP, but allows it to pass on to the operating system. So things like that. It's important that you use the right firmware. So the initial configuration is done via the console. You can either connect via the console or the SIMC, change the BIOS, so hit F2, and in the setup utility, choose the security tab and change the admin password, and like I said, make sure that the SIMC is distributed MLOM shared extended. Where do you connect the APIC? So here's an example of the SIMC and the 2 1 gig out-of-band management, which probably you would just want to use a single or dual ports to a VPC for your out-of-band management and your SIMC. And then you connect the APIC to 2 different leaves. So it should be dual home to 2 separate leaves via our 10 gig SFP. So in your SIMC network configuration, this is where I mentioned go into the admin tab to network settings and do shared LOM extended so that you can have all your SIMC on any of these MLOM out-of-band management ports as well as your out-of-band management. So on your first boot, the APIC is going to present an initial configuration wizard. And this is very important that you choose your options very carefully here because you only get one shot at this. Now, if you mess something up, of course, you can erase the entire APIC. There's an erase config setup option, and the setup option will take you back through this wizard. It'll erase all of your configuration and take you back through the wizard. Now, for a lab, that's highly desirable to use that. You might want to go back through the wizard, or at least you might want to erase your configuration and start over, factory defaulted, essentially. For a production environment, you don't want to have to do that. Now, if you did not, let's say you're watching this video and you find out that this default infrastructure VLAN that I'm going to talk about, 4093, which is the default, was left at 4093. And now what the problem is, well, you need to run Cisco AVS, the application virtual switch, which is a software VTEP or VXLAN tunnel endpoint leaf switch that runs in a hypervisor. And you need to run that, but you have to extend your infrastructure VLAN, this, out across the rest of your traditional switch network. in order to get AVS to be supported, okay? Because that's the VLAN that is tagged in the .1q header with the OpFlex protocol. And I know I'm getting very specific. We'll talk a lot more about that later, but it's important for this particular module. So let's say you realize, oh no, we're in production, we need to run AVS, this was never changed, and we need to extend this over a Nexus 7000 switch where VLAN 4093 is already reserved. So we cannot create a user-defined VLAN 4093 and use it to transit data traffic, like our APIC, OpFlex, infrastructure VLAN needs to have. So this could be a potential problem. There is a way around it, so it's not the end of the world. It requires backing up your configuration, which, by the way, when you back up your entire fabric configuration, I don't care if you have 200 leaf switches and 100 tenants and lots of application network profiles, you're not going to get beyond a few meg. In a small lab environment, it wouldn't even be 100K. So compare that to your show runs of old. And instead of having to have a bunch of show runs, you have a single tarball that has, it's compressed tarball, right? So GZ tar, and is comprised of a number of either XML or JSON text files. Okay, so you would back that up. Once you back that up or exported the configuration, then you would do your erase config and run back through the setup wizard, and then you would restore your configuration. So it's not ideal, but it's not the end of the world if you have already gone into production. So you're going to enter the name for the fabric. You could think of this as a domain. If you're going to, and probably you will, have multiple ACI fabrics, you're going to want to have separate naming conventions. How many controllers are in the fabric? So at the time of this, 3 is the default and the only supported. Which controller is this? So you'll do this one at a time, and you will issue, node 1, node 2, and then node 3. The naming convention, and this essentially is your host name, so you want to choose this in accordance with your existing naming convention. The IP address for your tunnel endpoints, this is what the fabric is going to hand out. This does not, it's in a separate VRF called the infrastructure VRF. Really, it's called overlay-1 is the actual name of the VRF on the switches. So this is not going to interfere with anything else that you have. If you are extending your infrastructure VLAN out across your fabric, this would be the IP address range that goes out across the rest of your traditional switch network, for instance, for Cisco AVS, or Application Virtual Switch, the hypervisor software switch. Okay? Now, again, it shouldn't cause a problem with anything else in your traditional network, even if there were otherwise an overlap, because you won't be routing anything to this network, or at least you shouldn't be. So you wouldn't probably have an SVI out on your traditional switch network. Okay, if you needed to have an SVI, then you may want to think of changing this, but make sure it's not any smaller than a /16. So a /8 would be plenty large enough. A /24, you will quickly run out of IPs. And you say there's 255. What if I only have 50 leaf switches? Well, there are multiple IPs that are given to leaf switches, and we'll talk about some of those and why as we go on. So our recommendation is to make this infrastructure VLAN 3967, which is the first of all the Cisco products that we've been through, the first non-reserved VLAN. I did have a client that had already, believe it or not, used 3967, but they didn't use any VLANs below 100, so we used VLAN 3 for that client. It cannot be 1. Your multicast group IP overlay is what GIPO stands for, and we'll talk a lot more about multicast later. And again, this is within the fabric. So it doesn't matter what multicast IP addresses you have coming into the fabric. This is going to be the overlay multicast group, the unique. So then the out-of-band management IP address, okay? And the gateway and interface. Do you want to enable strong passwords? What's the password? And then once you've done that, it does not redirect HTTP to HTTPS by default, so you do need to put in HTTPS and the IP address of the APIC. Now, like we talked about before, the switch nodes are going to have They are going to have their management port for out-of-band. That's our 1 gig. They're going to have a console serial port, like all Cisco switches do. And they also have in-band access. So this is an IP address that's assigned to a loopback that is used for internal management, not from the APIC, but by you. So if you happen to be not wanting to connect to one of the external interfaces to do management, but you actually want to manage everything from a device that's connected to a southbound 1 or 10 gig port on the ACI leaf switch, then you would set up your in-band management. So really there's 3 different types of management. There's out-of-band, actually 4 if you think about it. There's console, there's out-of-band, which is your management 0. There's in-band, which would almost be like on a traditional switch network if you were SSH connecting to one of the SVIs, for instance. But in this case, it's a loopback on its own management VRF. Then there's the infrastructure VRF, which is really called overlay-1, and that's where the APIC controls, talks to, and manages, and really even hands out the IPs for the leaf and spine switches. Okay, so the APIC is going to have 2 ports attached to the fabric for data and in infrastructure management, 2 for out-of-band management, and 1 console or Ethernet port. Okay, and then of course our SIM-C port, which is really what I meant by the Ethernet. So 1 console serial port. So let's talk about how the fabric gets initialized as well as maintenance. So the first thing is we boot up the APIC. Now we already have racked and stacked all of the rest of the switches and physically cabled them. But once we boot the APIC, we go through that initial cluster configuration, fabric name, tunnel endpoint address space, and the infrastructure VLAN in the infrastructure VRF, or overlay-1. So once we've gone through that wizard that we just got done talking about, then the APIC automatically detects via LLDP and the ACI-specific TLVs what leaf it's connected to. The leaf discovers it's actually connected to the APIC, and it requests its tunnel endpoint IP address, which is its loopback 0, and its boot file via DHCP. So think of this very similar to the old POAP, Power On Auto Provisioning, in Nexus switches. Once it's got all of that information, and we give it a node ID, and we reference this based on the serial number. So if we did everything through a RESTful API, we could just feed it a single JSON or XML file that had the serial numbers and the node IDs, and that's all the more we would need. If we're looking through the web user interface, we see the first leaf switch appear, and we see that it has a serial number. We identify the serial number based on which leaf switch we connected, because the APIC might be connected to more than one. And we know which one we want to call it, and then we go ahead and double click, and we'll actually go through and do this in a lab next, and then we from there go ahead and give it its node ID. Has to be greater than 100, and we recommend that your spines are actually your 100 series numbers, your 1XX, and that your leafs all begin with 2XX, because highly unlikely that in one single ACI fabric you're going to have more than 100 spines. If you do, then plan accordingly and maybe have 100 and 2XX series numbers for spines. But your leaf switches, you're probably going to have far more than. So 2XX through, let's say 9XX. Okay, those would be your leafs. So we'll go ahead from there, and once the first leaf switch is discovered and we've given it a node ID and it's configured itself, it will already be physically cabled to, and therefore LLDP will discover the first spine switch. Actually, technically it will discover all spine switches. So this animation could probably be updated a little bit because I have 4 spines. It would detect all 4 spines, and I would note those based on the serial number that I had already scratched down on a sheet of paper, and I would label them in the APIC controller. And again, you're probably going to want to keep your at least your leaf switches, probably your spine switches as well, labeled in your data center. So it would be important to note which serial numbers you're putting in which racks and which rows. So again, the spine is going to, via the 40 gig interface, actually, first of all, there's going to be an automatic configuration of IP addresses for the loopback and your IP unnumbered. So it's going to request its tunnel endpoint IP for its loopback 0 and its boot file, and then it's going to auto provision IP unnumbered for ISIS, and they'll have and form a point-to-point network. So then essentially the fabric will self-assemble, meaning that once we see all of our spines and we've assigned a node ID, actually once we've assigned a node ID to a single spine, since every leaf is connected to every spine, and that's the only supported topology for a class fabric, at least in this particular case, I should say with ACI, then at that point we're going to discover all of the other leafs through LLDP. And in case you're wondering, because I might switch it up, technically, in the Oxford English Dictionary, both leafs and leaves are both accepted. So hopefully I'll always say one, which is leafs, like the Canadian maple leafs, or Canadian, yeah, anyway. But leaves is perfectly acceptable as well. Okay, so now that we have that out of the way and I have you woke back up, your attention. By the way, it's very important you could power up all your APICs but not connect them, or that way they don't take a long time to boot. Make sure the rest of the APICs are not connected to the fabric during your initial fabric discovery, which is that wizard, and then all of the node ID assignments and the auto provisioning. Okay? Then you would attach, and this is going to show both APICs, but really you should attach one additional APIC. The second one, go through its wizard, give it its node ID of 2 and its name, and answer all the other questions the same. It's not like the UCS where it automatically detects its neighbor and just takes its configuration based on a security password. And then you have to give it all the information again. And then you attach the third, and you go through the wizard, and at this point, the appliance vector protocol will form a cluster. So this is kind of just a real quick screenshot, and we're going to go through this in person here in our demo. So this is where the fabric initialization and maintenance node identity policy are in the web user interface, under the fabric tab, under inventory, and under the left fabric membership. And we can either manually create a fabric node member if we want to pre-install before we attach, or we can let them auto show up. And we can go ahead and once we see their serial number come up, we can go ahead and assign a node ID. And another thing we could do is simply, this is a sample of an XML file. We could use JSON if we wanted and just replace controller.xml with controller.json. And we could post to, if this were our APIC IP address, we could simply post to /API, /node, /mo, /uni, /controller.xml or JSON with the serial number, name, and node ID. And the name is the host name, by the way. Okay, so this does get stored in /etc/hosts. The APIC and all the leaf switches are Linux boxes. This would be a very simple JSON or XML call, RESTful API call that we could make, and everything would be auto-provisioned. One-touch or zero-touch provisioning. And also this does control which switches can join the fabric. So I should really note that as well. This prevents rogue switches from just randomly attaching and auto-provisioning. They cannot until we acknowledge them and give them a switch name and a node ID. So then we do have different maintenance. So ACI Fabric does leverage the same global catalog methodology that UCS, Unified Computing System, uses, supported hardware, software, matrix, image versioning, and this is all controlled through policies in the APIC. Which images should be deployed on which group of devices or switches, when the images should be upgraded or downgraded, whether it's fully automatic or manual step-by-step. And typically, if we were upgrading the firmware, we would create, at a minimum, all odd number and all even number. So for instance, we could do all spines, all leafs, and all APICs. I prefer all odd number, so your odd number spine 1 and 3, leaf number 1, 3, and 5 would get taken out for upgrades. And let's say we have 2 top-of-rack switches, leafs, and these are VPC peers, and so are 3 and 4, and so are 5 and 6. We would take down 1 of those leaf switches for each VPC peer group, and we would recommend always an odd and even node ID. And then we'd take down 2 of the spines. Maybe we only had 2 spines. We'd take down the 1 of the spines. And then once that was done, ACI would then upgrade the evens. So even if we told it to upgrade odds and then evens and fully automated walked away, it would make sure that not only were the odd number spine and leaf switches back up, but that forwarding had recommenced before it began upgrading the odds. And it does the same thing with the APIC cluster. If I tell it to upgrade all 3, it'll actually download the APIC software to all 3, but it will only, even if I only uploaded it to a single APIC, it will distribute that, but it would only upgrade 1 APIC, wait till it's back and fully functional before it starts on the second one. Hands off. So it's actually probably one of the most amazing things in terms of upgrading a data center fabric. I've upgraded 2 spines and 26 leafs before, and the whole thing took about an hour, and it was mostly standing around waiting for it to do what it needed to do. Maybe about 15 minutes of my work. It's really quite amazing. So we've already talked about this. In terms of the management network, I won't go too much over this again, but we do have the infrastructure VRF called overlay-1, used for the in-band APIC to switch node communication. This is non-routable outside the fabric from a traditional sense, but we can extend it outside the fabric from a layer 2 perspective for AVS. We have the in-band management or management VRF created and there is a management tenant specifically created, as well as an infrastructure tenant for in-band management. Also, the out-of-band management for management 0 would be used in the tenant that's dedicated called management. So taking a look at the web interface of the APIC. Some of the basic elements are going to be things such as the top level. We have system, tenants, fabric, VM networking, L4 through 7, admin, and in the newer version there's a troubleshooting tab here as well. And then each of these top tabs or links has subtabs or subsections. So we have our main section. We then have our subsections. So for instance, for fabric, we have inventory, fabric policies, and access policies. And as we actually go through the web interface in the demonstration, I'll break these down into a lot more detail. When we first log into the APIC, to the web interface, we see the system dashboard. And this gives us an overall health of the entire system or fabric, our nodes that have anything less than or equal to whatever number we have, and we have a slider over here that we can choose. We can go all the way up to 100 to see everything, or we can slide this down to, let's say, nodes that are less than or equal to 80. Currently it's at 99. We can also see any tenants that have less than or equal to a particular health score. And this health score is, we're going to go into a lot more detail on it. It's one of the most amazing things about Cisco ACI, especially to your application developers, because RESTful API calls can be done from their applications to the APIC to find out how does their application, or even how does their tenant, how is it currently performing. So if we create an application and model it in an ANP, an application network profile, then we could say, what's the health of this ANP or this application? And it would return a value. And if there was a problem, we could then remediate. The application could automatically redirect all traffic, or redirect, maybe rewrite a GTM, global traffic manager from a load balancer perspective, or all sorts of things could be done to push traffic to another data center, to another cloud, whatever needed to be done, all controlled by the application. And at the same time, it could generate a ticket to the IT department saying, hey, you've got a problem. We've shifted all of our application off of this fabric and onto another cloud or fabric or data center or whatever. The application developer wanted to do this. They could even say, here's your specific problem. And based on queries that they had run through RESTful APIs, they could find out exactly what the problem is or problems with the fabric and report those back to the network admin. Most screens within the APIC are built upon a navigation pane and a work pane. So here, the left side is the navigation pane, and it allows navigation to all of the different configuration elements or management objects. And the nice thing about the navigation pane, it's not the most beautiful interface in the world, but it does really closely, or really, it accurately gives you a graphical representation of the management information tree. So it's very good for learning the management information model. And then the work pane, displays information about the component that you selected over here in the left nav pane. And we have a series of tabs, and many of those have subtabs, and a few of those even have sub-subtabs. So we have this hierarchical organization that, like I said, very closely follows the management information model. So we have folders and various tree nodes. Okay? These are known as parent and children objects, and we can do all sorts of things like save as, so we can back up any top level or bottom level child, or like I said, top level parent, and we can choose when we back it up, without backing up the entire system, to have all the configuration properties, or just a working subset of those. And we'll go into the distinct differences when we take a look at the demo. Actually, especially when we take a look at the RESTful API demo and subsection. And we can save it as either XML or JSON, and it will just back up that subsection. So it's great for contractors or consultants making templates of things without backing up an entire ACI fabric and all of the overhead that comes with that. Even though it's not a large size, overhead in terms of all the files that wouldn't necessarily be needed to, let's say, create a template or a model of a SAP application for an ANP, okay? Or for a common tenant that might have SAP and Microsoft Exchange and, I don't know, Microsoft SharePoint, for instance. Okay, as 3 ANPs or application profiles under that tenant. And then we also could even populate or do a post. This is an older screenshot that doesn't have the post in here, but we could also post it. And we can choose whether to include all the children or not. So all of the subcomponents to that tree. We could delete it, and it would delete everything underneath of it. There's also a consistency whether we want to, in the left nav, right-click, or over in the right work pane, which is not shown, all the way over at the right, there is an action button. And so we could click that action button, and we can do the same things as if we right-clicked on the particular element that was selected in the left nav pane. We have a basic elements table. So, for instance, this is currently showing us some faults, and we can grab any column and move it around in the dynamic HTML5 interface. We can click a drop-down and sort ascending or descending, show which columns are displayed, and hide certain columns if we don't want too much information, and then even use filters to, if we have 1,000 different records or entries, to only show, in this case, things that filter out with the cause of threshold crossed. We, of course, have pagination controls, so multiple pages, how many objects per page. We can download this information to XML, so maybe I'm looking at, let's say, for instance, I'm looking at all of my counters on a given interface or on a given switch node. I could download all of those counters to XML. I could also pause those counters so they're not dynamically updating. We'll take a lot more of a look at that when we look at counters. Everything here is via auto update, or I should say via WebSocket, which is a form of web programming that allows us to get dynamic two-way communication essentially, and not have to do a refresh of the page. Now, on occasion, certain times, maybe your web browser gets bogged down or something like that, your page may not update properly, so there is a little refresh button just to update that pane. But most of the time, you don't need it. So properties for any given left navigation, not pictured here. We have a consistent set of tabs across all of these different devices, or different left navigation objects. So here's another example where we're actually on a bridge domain navigation element on the left. And here we see, again, the page is always up to date by WebSockets, but you can refresh for peace of mind. Or if your browser gets overloaded, you can download the object. You can take actions, which are the same as the right click in the left navigation. We see all of these statistics. So here is a little bit more of an interface that I was talking about earlier. We can either see it like we see it now in graph view or in tabular format. One of these allows us to download. One of these allows us to select which counters we want to see. The stop kind of play control button, we can stop and then replay so that it will stop logging for a moment. We can choose whether we want to see it in graph or table view and then refresh for peace of mind. Health scores. We have this fan out and the ability to only look at problematic objects, so health scores that have a degraded performance. By default, this little actions gear has that tick box checked, which only shows elements that have a degraded performance rather than 100%. So even 99 is degraded. It's really not bad at all. And they are color-coded as well. So green, even if you see like let's say a 92, I think that's still going to be green. Okay? There's probably not too much of a problem with that. Keep in mind that ACI is going to report literally every possible fault. So it could be as simple as something, I'm trying to think of something really simple that could cause a problem or actually cause a fault, but it's not a problem. I can't think of anything off the top of, I don't know. But there could be really any minor number of things. CDP is not 100%, but it's green. It's probably not too much of a problem, and you can investigate why it's not 100. On any of these, I can click the plus, and it becomes a minus and shows the fan out of all of its subcomponents. And then you can double-click or drill down to find out what are the critical, major, minor, and informational or warning. So here's our critical, major. We have 2 minor, and actually this is 2 major faults, and then these are different counters of what could be occurring in the system. And we can click the plus and we can keep drilling down to find out, based on a degraded health score of a switch node, of a tenant, of an application network profile, even of an EPG, what is the actual fault. We also have a history tab, and we not only have faults that are currently going on, health score for the current, but we also have a history of faults, events, health score, and audit logs. So faults are obviously faults in the system. And we'll go into much more detail about these in the troubleshooting section. Events are what the system did and basically when. Okay, so maybe a switch port went up and down. This may have raised a fault, but it may have degraded the health score, but it wasn't a user, probably not a user configured thing. And then we have an audit log. So who made what change when? So this is something that we haven't really seen in the past. This is maybe one of the second most to health score, most exciting things about a unified system in ACI in general. So for instance, there is no, as long as you create multiple logins, and even if you are using the web user interface for everything, and let's say you have a small team of 5 people and everyone has root or super user or admin access. Make sure that you still create a separate user ID for each person and nobody uses admin. And that user ID is very representative or indicative of their name. Okay, that way you always have an audit log of who made what change and when. So at any point, if we have a degraded health score, let's say the health score degrades. We get a call to the help desk today, and someone says, hey, Microsoft Exchange was not working at all yesterday. Oh, great. Are you still having the problem? No, it's fine now. Okay. What time yesterday? I think it was around 1 p.m. It was right after I came back from lunch. Okay, we'll look into that. Thanks. Now, if that happened on a traditional network, how would you go back and look at the network? I mean, if you had extensive syslog and maybe Splunk set up, maybe you could go back and correlate all that. That'd be great. If you didn't have that advanced reporting set up, it would be very difficult. Today, we could just go back, and even if we did, we'd need to know which VLANs, which nodes. With ACI, we simply go look at the particular tenant that the user called in from, and we go look at the ANP for Microsoft Exchange. And we look to see in the history, health score, yesterday around 1 p.m., was there a degradation in health score? And we see, you know what, actually it dipped down to about 60%, yesterday at about 2. Okay, maybe that's what they were talking about. Maybe it was that close. Maybe they didn't remember the exact time. And then we could correlate that with audit logs. Did anything change right as the health score, and get the exact time code of when the health score degraded? Did anyone change anything from the audit log? And if so, who and what did they change? If not, what events occurred during that exact time stamp or beginning at that time stamp? What faults were raised? And so we can very clearly articulate a correlation between all of these events, faults, and who did what audit with the degraded health score. This is going to give you a ton of visibility and drive a lot of value into the network side of things into your actual business.